For 70 years, physicists agreed on one thing about your other selves. Yes, the equations may fill reality with versions of you. And no, you can never reach them because the wall between you is a law of nature, perfect and permanent. That was the consensus, right up until January of 2026, when a single paper quietly downgraded that law to a difficulty. Not impossible in principle anymore, just impossible in practice, which is a very different, much more open word. Tonight we walk slowly through how that wall was built and how it cracked, using only physics we already trust. Settle in, get comfortable, and subscribe. The question just stopped being closed. The wall everyone said was permanent. There is a question hiding inside tonight's title, and it is sharper than it first appears. The question is not whether a parallel universe exists somewhere out beyond the edge of everything we can see. That part, strange as it sounds, has more support in serious physics than most people realize. The real question, the one that keeps the title turning over in your mind, is this. Somewhere out there, in some other version of reality, there may be a version of you. And what if that version is not just sitting there as a frozen copy, going through the motions of a life almost like yours? What if that version knows? What if, in some way, we are about to spend the next couple of hours carefully unpacking another you is aware that you exist? For a very long time, the answer to that question was treated as closed. Not closed by religion, not closed by mysticism, but closed by physicists themselves, including the ones who fully accepted that other versions of you might be real. The standard line went like this. Yes, the equations of quantum mechanics may fill reality with countless versions of every person, every choice, every moment, but those versions are sealed away from one another. The walls between them are perfect. No message can cross. No signal can leak through. Your other selves might as well not exist, because you can never touch them and they can never touch you. The copies were said to be real and unreachable in the same breath, and that was the end of the discussion. And then, very quietly, in January of 2026, that discussion reopened. A paper appeared, the kind that does not make the evening news but makes a certain kind of physicist sit up very straight in their chair. The argument inside it was not that quantum mechanics needs to be rewritten, or that some exotic new force had been discovered. The argument was stranger than that, and in a way more unsettling. It claimed that, using nothing but standard, ordinary, textbook quantum mechanics, the kind taught in every university on the planet, the wall between those parallel versions of you might not be as absolute as everyone had assumed. That, under the right conditions, in principle, a message could cross. Now, I want to be honest with you right from the start, because this is a channel for the curious and not for the gullible, and the honesty is part of what makes the story worth telling slowly. This paper does not say that contact has happened. It does not say anyone has received a message from another world. It describes a thought experiment, a careful, logical argument that would require technology so far beyond anything we can build that it may never be built at all. It is a claim about what the equations permit, not a claim about what anyone has done. So, if you are hoping I am about to tell you that scientists have phoned up an alternate you, I have to gently set that expectation aside. But here is why it still matters, and why I think it is worth getting comfortable for. There is an enormous difference between two sentences that sound almost the same. One sentence is, "This is impossible in practice." The other sentence is, "This is impossible in principle." For 70 years, the second sentence was the one everyone used. The walls between the worlds were said to be a law of nature, a hard boundary written into the structure of reality, something that could never be crossed no matter how clever you were. What changed in 2026 is that the sentence got downgraded. The barrier started to look less like a law and more like a practical difficulty. A staggering, perhaps permanent practical difficulty, but a difficulty, not a prohibition. And when a wall stops being a law and becomes a difficulty, the question of what is on the other side stops being idle. So that is the journey we are taking tonight. We are going to separate two things that usually get tangled together. There is the feeling the title gives you, that quiet, slightly eerie sense that somewhere something is aware of you. And then there is the physics question underneath it, which is colder and more precise. Can information cross between versions of reality? We are going to start with the feeling, and we are going to end with the physics. And along the way, I think you will find that the physics is far stranger than the feeling ever was. To get there, we need to walk through a few things in order. The way you would walk through a house you have never been in, one room at a time. We need to ask which version of you we even mean, because it turns out there is more than one kind of parallel you, and they come from completely different corners of science. We need to understand why we never notice these other versions, which leads us to one of the most beautiful and underappreciated ideas in all of physics. And we need to understand the wall itself, what it is made of, before we can understand how anyone could ever claim to have found a door in it. I want you to hold one image in your mind as we go, because we will keep coming back to it. Picture a version of you who shared your entire life, every memory, every scar, every quiet morning, right up until some tiny, invisible moment, and then went a different way. Not a stranger in a distant galaxy. Someone who, a heartbeat ago, was indistinguishable from you. The distance between you and that person is not measured in miles or in light years. It is measured in something thinner and far stranger, and understanding what that something is made of is the whole point of the night. Because by the time we are done, the question will no longer be whether that other you exists. We are going to find that the existence of other versions of you is one of the most natural predictions of our best theories, arrived at independently by people who were not even looking for company. The question that will be left standing, the one nobody can quite close anymore, is whether the wall between you was ever as solid as we were told. So settle in. We are going to take this slowly, and we are going to start by sorting out exactly who or what is on the other side. Is less than break time equals 1s, is greater than number, part 2. Which you are we even talking about? When people say the words parallel universe, they almost always think they are talking about one idea. They are not. The phrase is a loose umbrella thrown over at least 3 completely different concepts, and those concepts come from separate areas of physics that were developed by different people for different reasons, often without any thought of one another. Each one produces a version of you, but a different kind of version, living a different kind of separate existence. Before we can ask whether any of them could know about you, we have to be clear about which one we mean, because the answer changes depending on the road we are standing on. The first road, and the one that matters most for tonight, comes from quantum mechanics itself. It is the idea that every time the universe faces a genuine quantum choice, reality branches, and a version of you branches with it. This version is the closest of all your possible doubles, because it was you, completely and exactly, up until the instant of the split. It carries your memories, your habits, the particular way you hold a cup of tea late at night. It diverged from you not in some distant epoch, but possibly seconds ago, on the outcome of an event so small you could never have felt it. This is the branch copy, and it is the version the 2026 paper is really about, so keep it at the center of your attention. The second road comes from cosmology, from the simple and dizzying possibility that space might be infinite. If space truly goes on without end, and if matter is spread through it with the kind of evenness we actually observe, then something remarkable follows by pure counting. There are only so many ways to arrange the particles in a region the size of everything we can see. A finite number of ways, enormous beyond comprehension, but finite. And in an infinite space, every possible arrangement must repeat, not once, but endlessly. Which means that somewhere, unthinkably far away, there is a region of space identical to this one, holding a planet identical to this one, holding a person identical to you, reading words identical to these. This is the infinite space copy, and it is real on this theory, but it is real in a way that turns out to matter enormously for our question, as you will see. The third road comes from the physics of how the universe began. Many of our best models of the first instance of creation suggest that the burst of expansion we call inflation did not switch off everywhere at once. In some descriptions, it never fully stops, and it keeps budding off new universes, like bubbles forming in a glass that never stops fizzing. Each bubble could have its own slightly different laws, its own values for the constants of nature. A version of you in one of those bubbles is far less likely, because the laws might not even permit beings like us. But the framework is taken seriously, and it gives us a third and grander kind of parallel reality. Now, here is the distinction that will run through this entire night, so I want to plant it carefully. The infinite space copy, the one impossibly far away across endless space, is unreachable for the simplest reason imaginable. It is too far. No signal traveling at the speed of light could ever cross that gulf in the lifetime of the universe, not even close, not by a margin so large the words lose meaning. That wall is built out of pure distance, and distance is a wall nothing can climb. But the branch copy, the quantum version of you, is sealed off by something completely different. It is not far away in space at all. It is, in a sense we will make precise, right here. The wall around it is made of something called decoherence, and decoherence, unlike distance, is a process. And a process, at least in principle, is the kind of thing you might one day learn to manipulate. Let me make that difference even more concrete, because it is the hinge the whole night turns on. Picture 2 locked rooms. In the first room, the lock is 1,000 miles of solid rock, with no tunnel and no tools, and a guard who will outlive the universe. That is the wall of distance around the infinite space twin. You are not getting through it, not because anyone forbids it, but because the geometry of the situation makes it flatly impossible to cross in any amount of time the cosmos will ever offer. In the second room, the lock is a door, an ordinary door, except that it has been sealed shut with a substance so strong that no force we currently command can budge it, and that hardens further the instant it is touched. That is the wall of decoherence around the branch copy. Both rooms are, for now, equally closed to you, but there is a difference between a room with no door and a room with a door you cannot yet open, and that difference is the entire reason this conversation is happening at all. That difference is everything. It is the reason that, of all the versions of you scattered across these theories, the only one that anyone could ever seriously argue might know about you is the quantum branch copy. The twin across infinite space is forever mute behind a wall of distance. The branch copy is behind a wall of process, and processes can be slowed, fought, engineered around. That is the thread we are following. I should pause to say something that I find genuinely moving about all of this. None of these copies of you were put there by a theory that wanted company. Nobody sat down and said, I would like to prove that other versions of people exist, and then built the mathematics to get there. It happened the other way around. Physicists built theories to explain things they could measure, the behavior of particles, the uniformity of the early universe, the way light spreads and interferes. And the copies of you fell out of those theories uninvited. Like an answer, the equations insisted on whether anyone wanted it or not. There is something honest about a strange idea that arrives that way, unasked for, as the price of taking your best mathematics seriously. So that is our map. 3 roads, 3 kinds of you, one of them the focus of everything that follows. But before we can ask whether the branch copy could ever reach across to you, we have to understand why physics started believing in branches at all. And that belief did not begin with a grand vision of parallel worlds. It began with a crack. A single, stubborn crack in the most successful equation human beings have ever written, a crack that has refused to close for nearly 100 years, and that every version of another you is, in the end, an attempt to repair. Is less than break time equals 1s is greater than number part 3, the crack in the equation. To understand where all of this comes from, we have to talk about a single equation, and I promise to do it gently, because the equation matters less than what it does. It is called the Schrödinger equation, written down in 1926, and it is, by almost any measure, the most successful piece of predictive machinery human beings have ever produced. It describes how quantum systems evolve over time, how the possibilities inside a particle shift and flow, and, in the roughly 100 years since it was written, it has never once been wrong in a laboratory. Not a single experiment has ever caught it making a bad prediction. When we use the related machinery of quantum theory to calculate certain properties of the electron, we get answers that match measurement to better than 1 part in a trillion. To put that in human terms, that is like measuring the distance across an entire continent and being off by less than the width of a single hair. This is not a theory we get to wave away when it says something uncomfortable. It has earned the right to be taken at its word. So what does it actually say? At its core, it describes something called the wave function, and the wave function is best thought of as a description of all the possibilities available to a system, evolving together, smoothly, predictably. Here is the part that breaks people's intuition, so let us go slowly. According to the equation, a single particle does not have to be in one place, or spinning one way, or travelling one path. It can be in what we call a superposition, which means several possibilities at once, all coexisting, all real in the mathematics, all evolving side by side. A particle's spin can point up and down at the same time. A particle can travel 2 paths at once. This is not a statement about our ignorance, about not knowing which one is true. The mathematics genuinely describes the possibilities as coexisting. The most direct way anyone has ever shown this is an experiment so simple in outline that it has been performed in classrooms, and so strange in its result that it has unsettled physicists for 2 centuries. You fire particles, one at a time, at a barrier with 2 narrow slits in it, and you let them land on a screen behind. Fire them one by one, each particle utterly alone, with nothing else around to interfere with, and you would expect each to go through one slit or the other and pile up in 2 simple bands. Instead, over many particles, the screen builds up a pattern of many stripes, the unmistakable signature of waves overlapping, of something passing through both slits at once and interfering with itself. A single particle, alone, behaves as though it explored both paths. That is superposition made visible. And here is the detail that matters for everything tonight. If you place a detector at the slits to catch which one each particle really goes through, the stripes vanish, and you get the 2 simple bands after all. The mere act of extracting which path information destroys the superposition. Hold that thought, because the destruction of superposition by leaking information into the world is the very thing that will later build the wall between you and your other selves. Now, picture a simple experiment. You have a particle in a superposition, spinning both up and down at once, and you build a device to measure which way it is spinning. You run the measurement. And here is the crack, the thing that has tormented physics for a century. You always, every single time, see exactly one answer. The needle points to up or the needle points to down. You never see both. You never see a blurry mixture. The smooth, branching, many-possibilitied wave function that the equation describes so perfectly somehow, at the moment you look, collapses down to a single definite outcome. And the equation that describes everything else so flawlessly says nothing, absolutely nothing, about why that happens or how. The earliest and most famous attempt to paper over this crack came from Niels Bohr and Werner Heisenberg and their colleagues around 1927 in what became known as the Copenhagen interpretation. Their move was, on the surface, simple. They said that when a measurement is made, the wave function collapses. The many possibilities become one. Before you look, the particle is in a superposition. The instant you look, reality picks an answer, and the rest vanish. For practical purposes, this works beautifully. Physicists have used it for a century to build lasers, transistors, the device you are listening on right now. But sit with it for a moment, and the problem surfaces. And once you see it, you cannot unsee it. What counts as a measurement? The equation governs the particle. Surely it also governs the atoms in your measuring device, because the device is made of particles too. Surely it governs the atoms in your eye, in your brain, because those are made of particles as well. So at exactly what point in the chain, from the particle to the device, to your retina, to your mind, does the smooth equation switch off and the magic collapse switch on? Copenhagen never said. It drew a line and called one side the quantum world and the other side the everyday world, and it never explained where the line is or why it should exist at all. It is a rule that applies to everything in the universe except the very act of looking at the universe, and a rule with an unexplained exception carved into the middle of it is not a finished rule. It is a placeholder. It is an admission that we do not yet understand something. It is worth appreciating just how uncomfortable this made the people who built the theory. Albert Einstein hated it and spent years inventing thought experiments to expose the absurdity of a particle with no definite properties until observed, famously asking whether the moon exists when nobody is looking at it. Bohr met every challenge, and the practical success of the theory was so total that most physicists simply stopped asking the awkward questions and got on with calculating, an attitude later summarized, half as a joke and half as a confession, by the phrase, "Shut up and calculate." For a whole generation, the crack in the equation was not so much repaired as politely ignored. The genius of what came next was to refuse the politeness, to insist that the crack was telling us something true about reality, and to follow it wherever it led, even if it led somewhere absurd. And this is the moment I want you to hold on to, because it is the seed of everything else tonight. Every single version of another you that we are going to discuss, the quantum branches, the infinite space twins, all of it is, in the end, a different attempt to fix this one crack without inventing a magic exception. Each one says, in its own way, here is how to explain why you only ever see one outcome without pretending that the act of looking has supernatural powers. The parallel versions of you are not a wild add-on dreamed up for fun. They are what you get when certain very sober people tried to make the crack close honestly. There is one repair in particular that is almost shocking in its simplicity. It says, what if there is no collapse at all? What if the equation that has never been wrong is just, completely, telling the truth, all the time, with no exceptions, even when you look? What if nothing special happens when you measure a particle, and the smooth wave function simply keeps doing what it always does? That single move, change nothing, just believe the equation, sounds like the most conservative idea imaginable. And it turns out to be the one that fills the universe with copies of you. The man who first dared to take it seriously was a graduate student, and for his trouble he was very nearly driven out of physics entirely. His name was Hugh Everett, and his refusal to add the magic exception is where the branching self begins. Is less than break time equals 1s. Is greater than number, part 4. Everett's Refusal. The man at the center of this story was named Hugh Everett III, and in the mid-1950s, he was a graduate student at Princeton, working under one of the most respected physicists of the age. What Everett did was, in a sense, the most conservative thing anyone had done with quantum mechanics in 30 years, and that is exactly why it sounded so radical. He looked at the crack we just described, the unexplained collapse, the magic exception carved into the middle of the equation, and he asked a question so simple it had been overlooked. What if we just delete it? What if we take the Schrödinger equation, the one that has never failed, and we believe every word of it, all the time, with no special rule for measurement at all? Follow the logic with me, because it is clean and it is relentless, and it leads somewhere astonishing. If the equation governs everything, with no exceptions, then it governs the particle you are measuring. Fine, everyone agreed on that. But it must also govern your measuring device, because the device is made of nothing but atoms, and atoms obey the equation. And it must govern the air in the room and the light bouncing around, and, crucially, it must govern you. Your eyes, your nerves, the atoms of your brain, all of it is made of the same quantum stuff, all of it bound by the same equation. There is no special substance in a human observer that exempts them from the physics that runs everything else. So what happens, Everett asked, when a person made entirely of quantum particles measures a particle that is in a superposition? The honest answer, the answer the equation actually gives if you refuse to add the magic collapse, is the kind of thing that stops your breath for a moment when you first take it in. The superposition does not collapse. Instead, it spreads. You become entangled with the particle. If the particle was spinning both up and down, then you become a superposition too. There is now a version of you who saw the needle point up, and a version of you who saw the needle point down. And both of them are equally real. Both are completely convinced they saw a single, definite result, and neither one is aware of the other. That is the whole idea, and notice what it does. It explains why you only ever see one outcome without any magic. You see one outcome because there is now a version of you for each outcome, and each version sees their own. The collapse was never needed. What looked like the universe picking one answer was really the universe branching, with a copy of you riding along on every branch. The crack closes. The price is the copies. I want to clear up something that gets this idea badly wrong in popular tellings, because the cartoon version is misleading and the real version is more beautiful. People imagine that each measurement causes the universe to split, to physically tear into two universes, with all the energy and matter somehow duplicated. That is not what the careful modern version says at all. Physicists like Sean Carroll and David Wallace, who have spent careers refining this, describe it differently. There was only ever one wave function, one single quantum description of absolutely everything, and it was always there in all its enormous structure. Nothing splits, nothing is created. Branching is just the name for what it looks like, from the inside, when parts of that one great wave function stop being able to interact with one another. The universe was always a layered thing. We are simply discovering the layers. This dissolves the objection that bothers people most, the one that goes, but where does the energy come from to make a whole new universe every time an atom does something? The answer is that no new universe is made. You are not minting fresh copies of reality. You are partitioning the one reality that was always there into pieces that can no longer feel each other. It costs nothing because nothing new is created. It is less like a cell dividing and more like a single piece of music separating into voices you had not noticed were always present in the chord. The human story of the man who saw this is genuinely sad and worth telling because it shows how hard it is to say something true too early. When Everett presented his idea in 1957, the physics community largely ignored it. The reigning authority on quantum mechanics found it unpalatable, and the disapproval mattered. Everett, discouraged, left academic physics almost entirely. He went to work for the defense establishment, doing classified research on the mathematics of nuclear war. He drank heavily. He died of a sudden cardiac failure at the age of 51, having lived to see almost none of the recognition his idea would eventually earn. It was another physicist, Bryce DeWitt, who revived the work in the 1970s, championed it, and gave it the name that stuck, the many worlds, the phrase Everett himself never used. There is an irony here that I find almost too perfect. Of all the ways to interpret quantum mechanics, this one, the many worlds, is routinely treated as the wildest, the most science fiction, the least serious, and yet it is the only one that adds nothing to the equations. Every rival interpretation has to bolt something extra on. A collapse mechanism, a hidden guiding wave, some new ingredient. The many worlds is the one that says, take what the mathematics already gives you and believe it, change nothing, add nothing. The most literal, least imaginative reading of our best theory is the one that fills reality with versions of you. And that brings us straight back to tonight's question, because in this picture, a version of you in a parallel reality is not exotic at all. It is not a strange possibility at the far edge of physics. It is the unavoidable consequence of taking the most successful equation in science at its word. Now, I owe you fairness, because this channel is not in the business of pretending things are settled when they are not. Plenty of serious, brilliant physicists reject the many worlds entirely, and they have real arguments. As recently as 2025, a paper appeared arguing that the interpretation, taken as a claim about literally real parallel worlds, contains an internal contradiction in how it handles the basic question of what actually exists. We are going to take those objections seriously later, because the honest state of this question is contested, not closed. But for now, hold the picture Everett gave us, because it has one more consequence we have not faced yet, and it is the one that makes this personal. If the branching is real, it is not some rare event that happens only in laboratories with special equipment. It is happening inside your body, right now, faster than any number you have ever held in your mind. Is less than break time, equals 1s, is greater than s, number, part 5, you are branching right now. Here is the consequence of Everett's idea, that turns it from an abstract puzzle into something that should make the back of your neck prickle, in the good way, the late-night way. If branching is real, it is not something physicists do to particles in a basement laboratory. It is something the universe is doing to you, continuously, without pause, whether or not anyone is measuring anything. Every time a quantum event in your body could go more than one way, and an unimaginable number of them can, reality branches, and a version of you branches with it. You are not waiting for a parallel self to appear in some distant future experiment. You are producing them, by the trillion, with every passing instant. Let me try to give that number something like a feel, because a raw figure means nothing on its own. A single gram of ordinary matter, about the weight of a paperclip, contains on the order of 10,000 billion atoms. Written out, that is a 1 followed by roughly 22 zeros. Every one of those atoms is a stage on which quantum events can unfold, and your whole body holds far, far more of them than a single gram. The quantum events ripple through that staggering crowd constantly. The honest estimate is that you branch more times in a single second than there have been seconds since the beginning of the universe. The universe is roughly 14 billion years old, which works out to something like 430 quadrillion seconds, a 4 followed by 17 zeros. And you outrun that entire history, that whole age of everything, in less than the time it takes to finish this sentence. That is the rate at which versions of you are coming into being. Where do these branch points happen? They happen everywhere in you, all the time, in ways you were built never to notice. A single photon of light strikes a cell in your retina, and whether it is absorbed at this instant or the next is a quantum matter, and reality keeps both. A potassium atom in your bones is faintly radioactive, and the precise moment it decays is one of the most purely quantum events there is, and reality keeps every possible moment. A sodium ion drifts across the membrane of a neuron in your brain as you have a thought, and the quantum details of that crossing fork the world. You are not a solid, single thing moving along a single track. You are a constantly dividing river, and you only ever feel yourself as one channel of it because of something we will get to very soon. I want to reframe the parallel you now, because the popular image is wrong in a way that matters for the title. People picture the other you as a distant figure, an alien double, living a life in some faraway cosmos, separated from you by gulfs of space. That is the infinite space twin we talked about, and it is real on its own theory, but it is not the branch copy. The branch copy is the opposite of distant. It is intimate. It shared your exact life, every memory, every moment, right up until some fraction of a second ago, and then a single quantum coin came up the other way, and it went on without you. It remembers your childhood because it was your childhood. It remembers the worst day of your life, and the best one, because up until the fork, those were its days too. Sit with what that means, gently, because this is the emotional center of the whole idea. Every choice you ever agonized over has a version where you chose the other way, and that version is not a fantasy or a regret. On this reading of physics, it is a real branch of reality, lived by someone who, up to the moment of choosing, was completely you. Every near miss you ever had, the step you didn't take off the curb, the message you almost sent, the turn you almost made, has a branch where it went differently, populated by a person who carries every memory you carry up to that fork. They are not strangers. They are the closest thing to you that could possibly exist while still being someone else. And the strangest part, the part that sets up everything to come, is that they are not far away in any ordinary sense. They are not across the galaxy. They occupy the same space you do. They are woven into the same single wave function that you are part of, just decohered into a portion of it that you can no longer reach or feel. Think of it less like two distant planets and more like two radio stations that started on exactly the same frequency and then drifted apart by an amount so tiny no dial could ever show it, until neither one can pick up the other's signal, even though both are still broadcasting, side by side, in the same air. The separation is real. The distance, in any way you normally mean the word, is essentially zero. I find it worth slowing down on just how relentless this branching is, because the scale of it is part of what makes it feel unreal, and feeling it properly is the point. Consider only the radioactive potassium in your own body. You carry a small amount of a naturally radioactive form of potassium in your bones and tissues, and it is decaying constantly, on the order of several thousand atoms every single second, each decay a quantum event whose precise moment the universe, on Everett's reading, keeps in every possible version. That alone, just the faint radioactivity of your own skeleton, is forking your reality thousands of times a second, every second, for your entire life, before we even count the photons landing in your eyes or the ions crossing your nerves. You are not occasionally visited by the quantum world. You are a quantum engine, throwing off versions of yourself the way a fire throws off sparks, and you have been doing it without pause since before you were born. And the thing that makes this intimate, rather than merely enormous, is the shared history. A copy of you produced by a branch event 1 minute ago remembers everything you remember up to 1 minute ago perfectly, because it was you up to 1 minute ago. It is not an approximation of you, not a sketch, not a character loosely based on you. It is you, continued along a different outcome, with a past that is your past in every detail. As the minutes and the days accumulate, that copy drifts further from you, lives different mornings, makes different mistakes, becomes someone increasingly distinct. But it began as you, completely. And that beginning is what the title is reaching toward when it imagines a version of you that might know you. It would not be a stranger learning of your existence. It would be, in a sense, you learning that another path of yourself went on without you. So we arrive at the obvious and the right objection, the one you have probably been holding for several minutes. If these other versions of me are right here, sharing my space, woven into the same reality, why can I not sense them in any way at all? Why is there not the faintest whisper, the slightest pull, the smallest hint that they are there? And the answer has a name we have circled twice now without explaining. The answer is decoherence. It is the wall. It is the reason the branches behave like separate worlds, even though they are, in the underlying mathematics, all part of one. And here is what makes it the perfect thing to understand next. The wall that hides your other selves turns out to be made of exactly the same physics that engineers spend billions of dollars and entire careers fighting against. Inside the most advanced machines humanity has ever attempted to build is less than break time equals 1s is greater than number part 6. The wall, decoherence. Decoherence is one of those words that sounds forbidding and turns out to describe something almost intuitive once you sit with it. So let us take it slowly, because understanding this wall is the key that unlocks the rest of the night. The basic puzzle it answers is this. Single particles do impossible-seeming quantum things all the time. They exist in superpositions, in several states at once, they interfere with themselves, they refuse to commit to a single reality. And yet you have never once seen a coffee cup in two places at the same time, or a chair both here and there, or a person blurred across two outcomes. The strangeness is real, at the scale of the very small, and utterly absent at the scale of the everyday. Decoherence is the explanation for why the magic drains away as things get bigger. Here is the mechanism in plain language. A quantum system can only stay in a clean superposition, with all its possibilities able to interfere with one another, as long as it stays isolated. The moment it interacts with its surroundings, something subtle and irreversible happens. Information about which possibility is which leaks out into the environment. Imagine a particle in a superposition of two paths. As long as nothing touches it, those two paths can recombine and interfere, producing the unmistakable signatures of quantum behavior. But let a single stray photon bounce off the particle, or a single air molecule bump into it, and that photon or molecule now carries away a record of which path the particle took. The which path information has escaped into the wider world, and once it has escaped, the two possibilities can no longer interfere. They have, in the technical term, decohered. They still both exist in the full mathematics, but they have stopped being able to feel one another. This is not some fringe speculation or a controversial interpretation that you have to take on faith. Decoherence is measured, mainstream, thoroughly understood physics. The groundwork was laid by Heinz-Dieter Zeh around 1970 and developed in detail through the 1980s and 90s, most influentially by Wojciech Zurek. It is one of the few parts of this entire story that essentially every physicist agrees on, regardless of which interpretation of quantum mechanics they favor. Whatever you think reality is doing underneath, decoherence is the well-tested account of why the quantum world hides itself so completely at human scale. Now let me give you a sense of how fast this happens, because the speed is the whole reason you have never caught a hint of your other selves. Consider a single speck of dust, far too small to see clearly, floating in ordinary air. If you somehow put that dust speck into a superposition of two nearby positions, how long would it survive before decoherence destroyed the possibility of interference? The answer is roughly 10 to the minus 31 seconds. That is, a decimal point followed by 30 zeros and then a 1 of a second. To try to feel a number that small, imagine you could stretch a single second out until it was as long as the entire age of the universe, all 14 billion years of it. Even on that absurdly stretched timeline, the dust speck would finish decohering in less than the blink of an eye. For something the size of a person, the time is so much shorter still that the words for it stop meaning anything. This is why you are only ever aware of one branch. The others wall themselves off in a span of time so brief, it is essentially instantaneous. It helps to put a famous image on this, the one almost everyone has heard of, and almost everyone slightly misunderstands. In 1935, Erwin Schrödinger imagined a cat sealed in a box with a device that would kill it if a single radioactive atom decayed, the decay being a purely quantum event in a superposition of having happened and not happened. The naive reading says, the cat is therefore both alive and dead until someone opens the box, and people usually treat this as a paradox meant to show how absurd quantum mechanics is. But decoherence reframes the whole picture. The cat is a warm object made of something like a billion particles in constant contact with the air, the walls of the box, its own body heat. The instant the quantum trigger interacts with anything that large, the which outcome information floods into all those particles, and the alive branch and the dead branch decohere from one another almost immediately. There is no eerie, blurred cat waiting for an observer to resolve it. There is simply a branch where the cat lives, and a branch where it does not, walled apart in a fraction of a moment, each one as real and as definite as the other. Schrödinger meant the story as a mockery of the theory. Decoherence quietly turned it into a lesson about exactly how, and exactly how fast, the branches seal themselves away. The quantum computing connection deserves a little more weight, because it is the most concrete proof that this wall is something we already grapple with physically rather than philosophically. The reason the largest technology companies and governments on Earth are pouring billions into refrigerators that chill chips to within a fraction of a degree of absolute zero, into vacuum chambers and layers of magnetic shielding, into error-correcting schemes of dizzying complexity, is that every one of those measures is, at bottom, an attempt to delay decoherence. A qubit that holds its superposition for a few millionths of a second is, by today's standards, a real achievement. A few millionths of a second, set against a dust speck's 10 to the minus 31, shows you both how far the engineering has come and how monstrously hard the fight remains. And the point I want you to carry forward is this. Every time a research team announces that they have extended a qubit's coherence time, they are, in the most literal sense, available to us, holding two branches of reality, able to feel one another for a little longer than before. They would never put it that way in a press release, but that is what coherence is. And here is where this becomes more than an abstract explanation, because the very same physics is the central enemy of one of the most ambitious technological projects of our era. When engineers try to build a quantum computer, the entire thing they are trying to protect is a superposition. A quantum bit, a qubit, is valuable precisely because it can hold several possibilities at once, the way a single particle can. And that is what gives a quantum computer its strange power. But a qubit is only useful while its superposition survives, while it stays coherent, and decoherence is constantly trying to destroy it. Every stray vibration, every wandering photon, every faint pulse of heat threatens to leak the qubit's witch state information into the environment and collapse its usefulness. The whole brutal engineering war of quantum computing, the dilution refrigerators, chilling chips to a hair above absolute zero, the elaborate electromagnetic shielding, the desperate race to do calculations in millionths of a second, is one long battle to hold decoherence off for just a little while longer. So look at what we have found, because this is the connection that matters for everything to come. The wall that hides your branch copy from you is decoherence. And the enemy that a quantum computer fights every microsecond of its operation is decoherence. They are not similar problems. They are the same problem. Keeping the branches of reality able to feel one another and keeping a qubit alive long enough to compute are, at the level of the physics, the identical challenge. The fragility that makes quantum computers so maddeningly hard to build is the exact mechanism that walls your other selves out of reach. There is one more subtlety I have to give you before we leave this room, because it is the seed from which the rest of the night grows, and it is easy to get wrong. Decoherence does not make the other branches disappear. It does not delete them or push them out of existence. They are all still there, every one of them, in the full wave function. What decoherence does is make the interference between them practically zero. And I have to lean on that word practically, because it is doing enormous work. The interference is not made exactly zero. It is suppressed, driven down by factors so large they dwarf the number of atoms in the entire observable universe. For any purpose you could ever have, it is gone. But suppressed almost to nothing and made truly, mathematically nothing are not the same statement. And a system specifically engineered to resist decoherence, to hold its coherence against the constant assault of the environment, is not a fantasy. It is, once again, exactly what a quantum computer is straining to be. So when we talk about the wall between you and your branch copy, we should be precise about what it really is. It is not a law of nature forbidding contact, written into the foundations of reality. It is a process, an astonishingly, almost unimaginably effective process, but a process of the very kind our most advanced machines are, already, clumsily, learning to slow down. And if the wall is a process rather than a law, then we have to ask how many other ways there are to make a copy of you, and whether any of those copies sits behind a wall we might actually learn to cross. Is less than break time equals 1s is greater than number part 7. The copy you could, in principle, drive to. We have spent a long time on the branch copy, the quantum version of you that decoherence walls away, and we will return to it because it is the center of everything. But I promised you 3 roads to another you, and to understand why the branch copy is special, you have to see one of the alternatives clearly. So let us leave quantum mechanics for a while and step into cosmology, into the simple and staggering possibility that space itself might be infinite. Because if it is, then there is another version of you out there, of an entirely different kind, and the difference between that one and the branch copy will tell us something crucial about the title's question. The idea comes most clearly from the work of the physicist Max Tegmark, who in 2003 laid out a map of the different ways our universe might be one among many. He sorted them into levels, and the most basic one, the one he called Level 1, does not require any exotic physics at all. It requires only 2 things we have good reason to believe. First, that space is infinite, or at least so enormous it might as well be. And second, that matter is spread through that space with a kind of overall evenness we actually observe when we look at the largest scales. Grant those 2 things, and a conclusion follows that you cannot escape, no matter how much you might want to. Let me walk you through the reasoning, because it is pure counting, and it is oddly beautiful. Take a region of space the size of everything we can currently observe, the entire visible universe out to its furthest horizon. Ask how many physically distinct ways the matter inside such a region could possibly be arranged. Now, that number is enormous, beyond any ordinary meaning. But here is the key point. It is finite. There are only so many particles, and only so many states each can be in, so there is a finite, if titanic, number of distinct ways to build a region that size. And in an infinite space, you have infinitely many such regions to fill. When you have infinitely many boxes, and only a finite number of distinct ways to fill each one, repetition is not likely. It is forced. It is guaranteed. Every possible arrangement must occur, not once, but infinitely many times. Among those arrangements is this one: the exact configuration of every particle in the region around you right now, including the particles that make up this planet, this room, and you. Somewhere in an infinite space, that arrangement repeats exactly, which means there is a region identical to this one, holding a person identical to you, hearing words identical to these, having the exact thought you are having now. And not just one, infinitely many versions of you living this precise moment, and versions living every slight variation of it, and versions living lives that diverged from yours long ago, all of them real, all of them out there, if space is truly endless. If the counting still feels too abstract to trust, try a smaller version of the same logic. Imagine a deck of cards with only a handful of cards in it, and imagine shuffling it over and over forever. Because there are only so many possible orders for a small deck, you are guaranteed, given enough shuffles, to see every order eventually, and to see each one again and again without end. Now, scale that intuition up. A region the size of the observable universe is, in effect, a deck with an almost incomprehensibly large but still finite number of possible arrangements of its matter. An infinite space is an infinite number of shuffles. The same guarantee applies, only now the orders being repeated are not card sequences, but entire universes, entire worlds, entire lives. Repetition stops being a curiosity and becomes a mathematical certainty, and you, exactly as you are right now, are one of the patterns being dealt again and again. How far away is the nearest exact copy? Tegmark worked through the counting, and the answer is a number that breaks the mind in a particular way. Your closest identical twin sits roughly 10 to the power of 10 to the power of 28 meters away. I want you to notice something strange about that figure. It is so large that the units barely matter. Whether you measure that distance in meters, in light years, or in the width of a single atom, the answer is essentially the same, because the exponent is so colossal that the relatively tiny difference between those units cannot move it. For comparison, the entire observable universe is only about 9 times 10 to the 26 meters across. The distance to your copy is not just bigger than the observable universe. The exponent describing it is itself larger than any ordinary distance you could ever name. And here is the contrast that matters for tonight, the reason I brought you down this road at all. This infinite space copy is real, on this theory, but look at the wall around it. It is sealed away by sheer distance, and distance is the most hopeless wall of all. No signal, no message, nothing travelling at the speed of light or any speed nature allows could ever cross that gulf, not in the lifetime of the universe, not in 1 trillion lifetimes of the universe, not by any margin that leaves the words their meaning. The wall of distance is perfect and permanent because nothing can outrun it, whereas the branch copy, the quantum version of you, is walled off not by distance, but by decoherence, which, as we just saw, is a process and not a law. That is the whole point. Of all your possible doubles, the infinite space twin is the one most hopelessly out of reach, sealed behind dead distance forever, while the branch copy sits behind a wall of the only kind that anyone could ever dream of thinning. I should sketch the higher levels quickly, just so you have the full map, because the multiverse is not one idea, but a layered one. Above level 1 sits level 2, the bubble universes born from eternal inflation, which might have different values for the constants of nature, different strengths of gravity, different rules. Above that, level 3 is Everett's quantum branches, the very thing we have spent most of the night on, now revealed as just one flaw in a taller structure. And at the top, level 4, the most abstract of all, is the idea that every self-consistent mathematical structure describes a real universe somewhere, that the multiverse is, at bottom, made of mathematics itself. We do not need to climb all the way up tonight. I mention it only so you can see that when someone says parallel universe, they might be pointing at any one of these very different flaws. It is worth pausing on how unlike one another these levels truly are, because lumping them together is the source of endless confusion. The level 1 copy of you, the infinite space twin, lives in our universe, under our exact laws of physics, just impossibly far away. The level 2 copy, if there is one, lives in a different bubble that might run on entirely different physical constants, where the strengths of the forces and the masses of the particles could be wildly unlike our own. The level 3 copy, Everett's branch version, is not somewhere else in space at all, but in the same place, decohered into a part of the shared wave function. They are not 3 locations on one map. They are 3 different meanings of the word elsewhere, and the title's question lands differently on each. Only for the level 3 copy, the quantum branch, does the word elsewhere refer to something close enough and walled off by a process rather than a distance that contact is even worth discussing. I want to be scrupulous about the honesty here, because it is easy to state level 1 as if it were proven, and it is not. The whole edifice rests on space being genuinely infinite, and we have not measured that and may never be able to. What we have measured is that the geometry of the universe is extremely close to flat, and that the matter in it is extremely evenly spread. And both of those facts fit naturally with the kind of inflation that tends to produce an infinite or near infinite space. So level 1 is a strong inference from things we can measure, not a fact we have measured directly. It is reasonable. It is well motivated. It is not certain. There is a question that surfaces here and refuses to leave, and it is worth letting it surface rather than hurrying past. If there are infinitely many copies of you, each identical down to the last atom, each having this exact thought, then which one is the real you? The unsettling and honest answer is that the question may not even mean anything. There is nothing that distinguishes you, here, from your identical twin across that unthinkable distance, no fact of the matter that makes one of you the original and the other the copy. You are each equally and fully you. The word original quietly loses its grip. And that is a strange thing to absorb late at night. The idea that the singular sense you have of being one specific person, the only one looking out through these particular eyes, might be a kind of useful illusion, true only from the inside, with no support at all in the structure of an endless universe. There is a strange double feeling that comes with all of this, and I think it is worth naming before we move on, because it sits underneath the title. On one hand, there is something almost comforting in the thought that in an infinite universe, every version of your life is lived somewhere. Every happiness you missed is real for some copy of you. On the other hand, there is something quietly unbearable about it, the thought of infinitely many of you, each certain they are the only one, each as real and as alone as you are right now. But notice what the title is really asking, and bring it back to the thread. The title does not ask whether a version of you exists. We have now found 2 completely independent reasons to believe one does, from quantum branching and from infinite space, arrived at by separate physics that never agreed to cooperate. The title asks whether one of them could know about you, and the infinite space twin, real as it may be, is forever mute behind a wall of distance no signal can ever cross. Which means the only version of you that could ever, even in principle, reach across to you is the branch copy, sitting behind a wall we have already begun, in our crudest machines, to learn how to manipulate. So before we ask whether that wall can truly become a door, we should look at the one place in all of science where another universe might have left a fingerprint we can actually photograph. Is less than break time equals 1s. is greater than number. Part 8. A Bruise in the Sky. There is a possibility I have only touched on so far, and it deserves its own moment, because it is the one route in this entire story where another universe might leave a mark we could actually see with telescopes in real data. It comes from that second level of the multiverse, the bubble universes, and from the idea called eternal inflation. The short version is this. Many of our best models of the universe's first instance suggest that the explosive expansion we call inflation does not switch off everywhere at the same time. In some regions, it stops and settles into a calm universe like ours. In other regions, it keeps going and keeps spawning new pockets, new bubbles, each one a universe of its own, in a process that may never truly end. Now here is the tantalizing thought. If our bubble universe formed alongside others, and if, in the chaotic early moments, our bubble ever brushed up against a neighboring one, that collision would not be silent. It would leave an imprint. Specifically, it could leave a faint, particular pattern stamped onto the oldest light in existence, the cosmic microwave background, the afterglow of the early universe that fills the entire sky and that we have been mapping in ever finer detail for decades. A collision between universes would be, quite literally, a bruise, a place where another reality pressed against ours and left a mark. And this is where it stops being purely hypothetical, because there is a feature in that ancient light that has puzzled cosmologists for years. It is called the cold spot. In one region of the microwave sky, spanning a patch of the universe something like 1.8 billion light-years across, the temperature of that ancient glow is unusually low, around 70 millionths of a degree colder than its surroundings. That may not sound like much, but on the exquisitely uniform canvas of the early universe, it stands out. The usual explanation is that a giant region of relatively empty space, a so-called supervoid, lies between us and that patch, cooling the light as it passes through. But that explanation has struggled to fully account for the size and the depth of the cold spot, and that struggle has left a door open for stranger ideas. Some researchers, Tom Shanks at Durham University among them, have raised the possibility that the cold spot is the bruise, the scar left where our universe collided with another. I have to be careful and fair here, because this is exactly the kind of claim that gets wildly oversold, and I do not want to do that to you. The bubble collision reading of the cold spot is a minority hypothesis. It is not confirmed. A cold patch of roughly that size could arise by simple chance within our standard picture of cosmology, with a probability of perhaps 1 or 2%, which is small but very far from negligible. So the responsible position is that the cold spot is an anomaly, an open question, with several possible explanations, of which a collision with another universe is only one, and not the frontrunner. What gives the idea a way to be tested, and this is the part I find genuinely hopeful, is that a true bubble collision should leave a specific signature in the polarization of that ancient light, a particular twist in how the light waves are oriented. Future surveys mapping the polarization of the cosmic microwave background could, in principle, settle it, either finding the predicted pattern or ruling it out. So why does this belong in tonight's story, when it is about bubble universes rather than the branch copy we keep returning to? It belongs because of what it would mean if it were ever confirmed, and you can already feel the connection forming. The textbook claim, the comfortable consensus we started the night with, was that the walls between universes are absolute, that no universe can ever affect another in any way. But a bubble collision is two universes physically touching, pressing against one another hard enough to leave a mark we could one day read in the sky. If that ever turns out to be real, then the idea of a perfectly sealed barrier between worlds is already wrong, already softer than the textbook insisted, in the most concrete way imaginable, written across more than 1 billion light-years of ancient light. And that is the same softening we keep finding everywhere we look tonight. The walls keep turning out to be processes and circumstances rather than iron laws. Which brings us to a different kind of wall altogether, not between universes, but between observers, and to an experiment that suggests two people may not even share the same set of facts within a single universe. Is less than break time equals 1s is greater than number. Part 9, Whose Facts Are Real? We need to talk about a thought experiment that, until recently, lived entirely in the realm of philosophy, and that has lately stepped, astonishingly, into the laboratory. It was first posed by the physicist Eugene Wigner in 1961, and it is usually called Wigner's friend. The setup is simple to describe and difficult to digest. Imagine a friend of yours, a competent physicist, sealed inside a perfectly isolated laboratory. Inside, the friend measures a quantum particle, say the polarization of a photon, something that before the measurement was in a clean superposition of two possibilities. The friend looks at the result, records it, and now knows a definite answer. From the friend's point of view, inside the lab, the matter is settled. The photon was one way or the other. Reality picked. But now, consider your point of view, standing outside that sealed laboratory with no information about what the friend saw. From the outside, nothing has decohered into your world. The lab is isolated, by assumption, perfectly. So according to quantum mechanics applied honestly, the way Everett taught us to apply it, you must describe the entire contents of that lab, the photon and the friend together, as one single, enormous superposition. From your description, the friend is in a superposition of having seen one result and having seen the other. The friend inside says the answer is definite. You, outside, say the friend is in a superposition of two contradictory states of knowledge. And here is the paradox in its sharpest form. Both of you are using quantum mechanics correctly. You are not making a mistake, and neither is the friend. You simply have two different, apparently incompatible descriptions of the same event. So whose description is the real one? Which of you is holding the actual fact about what happened? For decades, this was a puzzle you argued about over coffee, with no way to test it. That changed in 2019. A team of physicists, Massimiliano Proietti and colleagues, figured out how to build an extended version of the Wigner's friend scenario using 6 photons, with the photons themselves playing the roles of the observers and their friends. By measuring correlations across this little system, they could test whether the different observers' results could all be facts in one shared, observer-independent reality, or whether that was impossible. The experiment was, in effect, a Bell-type test, the same family of tests that earlier proved the universe cannot be both local and have definite hidden values, and the result came down clearly. The inequality was violated by 5 standard deviations, which in physics is the threshold for a serious claim. Let me state what that means as carefully as I can, because it is easy to overstate, and the truth is strange enough without exaggeration. If you want to hold on to 2 very reasonable-sounding assumptions that distant events do not instantly influence one another, and that experimenters can freely choose what to measure, then the result implies there is no single, shared, observer-independent set of facts about the world. The friend's fact and your fact in the Wigner scenario cannot both be part of one objective reality that everyone agrees on. Reality, at the level of recorded measurement outcomes, can genuinely be different for different observers. This is not a metaphor and not a philosophical mood. It is the conclusion drawn from a real experiment with real photons, published in 2019. I think this is one of the most underappreciated results in modern physics, and most people have never heard of it, which is a quiet shame. We are raised to believe that facts are facts, that what happened, happened, and that any 2 honest observers must in principle agree on the events of the world, even if they disagree about their meaning. This experiment suggests that comforting assumption may simply be false at the quantum level. Observer-dependent facts are no longer a seminar room speculation. They are an experimental finding. And I have brought you here to this strange little result for one specific reason, which ties directly back to the thread we have been following all night. This experiment is the exact doorway that the 2026 communication argument walks through. Because once you accept that different observers can hold genuinely different facts, that reality does not enforce one shared account of events, then the question of whether one observer version could somehow send a message to another observer version stops sounding like nonsense. It starts sounding like a question with an answer, and working out that answer is what the most provocative paper in this whole story set out to do. Is less than break time equals 1s is greater than number, part 10. The 2026 argument. We have arrived, finally, at the paper that made me want to spend a whole night on this question, the one that appeared in January of 2026, and quietly reopened a discussion everyone thought was finished. So, let me bring the spine of the night back into focus. For 70 years, the consensus was that the branches of reality, the worlds of Everett, are sealed off from one another absolutely, that decoherence builds a wall no message could ever cross, and that this was simply a fact about how the universe works. The paper's claim is that this consensus was too strong. That inter-branch communication, a message passing from one version of an observer to another, is possible within standard quantum theory. No new physics, no rewriting of the equations, just a consequence, the authors argue, was hiding in the mathematics all along, waiting for someone to take it seriously. Let me lay out the idea in plain language, because the actual setup is more elegant than you might fear. Take the Wigner's friend scenario we just walked through, the friend sealed in the isolated lab, in a superposition of having seen two different results from the outside observer's point of view. In the ordinary telling, that is where the story ends, a paradox to puzzle over. But now imagine you do not merely stand outside the lab passively. Imagine you, the outside observer, have genuine quantum control over the friend and the entire contents of the lab. Imagine the friend is not allowed to decohere, not allowed to leak their witch result information out into the wider world, but is held with exquisite care in a clean and lasting superposition. The friend exists fully as both versions at once, and crucially, that coherence is maintained rather than destroyed. Under those conditions, the authors argue, something becomes possible that the standard story said never could be. A message written by one branch version of the friend can be received by a distinct branch version of that same friend. One version, the one who saw result A, can in effect leave a mark in the shared quantum state, and the other version, the one who saw result B, can read it. The two versions of the observer, which decoherence would normally wall apart into separate worlds with no contact, can pass information between them precisely because the coherence that decoherence usually destroys has been preserved. The branches, held coherent, can touch. I want to dwell on what makes this radical, because it would be easy to nod along without feeling the weight of it. This is not a proposal to modify quantum mechanics. It is not some speculative new theory that competes with the standard one and might be wrong. The authors are working entirely inside the equations that every physicist already accepts, the same Schrödinger equation that has never failed, the same framework taught in every graduate program on Earth. They are claiming that the prohibition on interbranch communication was never actually a theorem of quantum mechanics. It was an assumption, a very reasonable assumption, given that decoherence is so brutally effective in practice, but an assumption nonetheless. And when you remove the assumption and ask what the bare equations permit, the wall develops a door. Now I have to do the thing this channel exists to do, which is to tell you the truth about the limits, at length, because the limits are enormous, and they are the whole reason this remains a thought experiment rather than a headline. To do what the paper describes, you would need to maintain perfect quantum coherence over an observer, not over a single particle, not over a small handful of atoms in a chilled chip, but over something complex enough to count as an observer, something that measures and records and, in the fullest version of the idea, knows. And you would need to do this while shielding that observer from essentially every photon, every air molecule, every faint pulse of heat, every possible interaction with the outside world, because any one of them would leak the witch result information out and collapse the whole delicate arrangement into ordinary, sealed-off branches. The instant decoherence wins. The door slams shut and becomes a wall again. Hold that against what we learned earlier, and you will feel how far this is from anything we can build. Recall the dust speck, decohering in 10 to the minus 31 seconds. Recall that a person-sized object decoheres so much faster still that the timescale loses all meaning. Recall that the brain, the most observer-like thing we know, runs on roughly 20 watts of power and is made of warm, wet, churning matter in constant violent interaction with its surroundings, which is about the least isolated, most decoherence-prone environment you could possibly imagine. The engineering challenge of holding such a thing in clean superposition is not merely difficult. It may be permanently, fundamentally beyond reach, forbidden not by the letter of the equations, but by the sheer impossibility of isolating warm, complex matter from a universe that is constantly touching it. So when I say the paper found a door, I do not mean an open door. I do not mean a door anyone can walk through. I mean that where for 70 years there was said to be solid, seamless stone, a law of nature, there is now understood to be a door, even if it is a door welded shut by the most extreme practical barrier in all of physics. And notice how this single argument gathers up the two threads we developed earlier, because this is where they were always heading. The wall it proposes to engineer around is decoherence, the exact process we spent so long understanding, the same enemy quantum computers fight every microsecond. The foundation it builds on is the observer-dependent reality of the Wigner's friend experiment, the genuine result from 2019 showing that different observers can hold different facts. The paper takes the wall from one room and the doorway from another and fits them together. It says, in effect, here is the wall, decoherence, and we know it is a process, not a law, because our machines already fight it. And here is the doorway, the observer dependence that experiment has confirmed is real. Put them together correctly, hold the coherence, and the versions of the observer can communicate. The whole structure of the night was leading here. I owe you the skeptics, because this is a preprint and a thought experiment, and the disagreement is real and serious. Many physicists will argue that the protocol is unphysical in a stronger sense than mere engineering difficulty, that maintaining coherence over a genuine observer may be forbidden by deeper principles we do not yet fully understand, perhaps involving gravity, perhaps involving the very nature of what it means to be a record-keeping system. Others will question whether what the protocol achieves should really be called communication between worlds, or whether it is better described as the branches never having fully separated in the first place, which would make the language of contact misleading. The honest state of this idea is contested. It is provocative, it is published as a preprint, it has not been demonstrated, and reasonable experts will tell you it may never amount to anything. I am not selling you a triumph. I am showing you a crack in a certainty. But here is why even a contested crack is worth a whole night of your time, and why it speaks so directly to the title. For 70 years, the question of whether a version of you in a parallel branch could ever know about you was not a scientific question at all. It was filed away as impossible in principle, which is the category we reserve for things not worth thinking about, like a square circle or a number larger than every number. What this paper does, whether or not it ultimately holds up, is move the question out of that category. It makes whether a version of you could know about you into a question about engineering and physical limits, about coherence times and isolation and energy, and the underlying structure of measurement, rather than a question about whether the thing is even conceivable. The thing is now conceivable. The argument for its conceivability uses only physics we already trust. That is a genuine change, and it happened in your lifetime, a few months ago, in a paper most people will never hear about. Which leaves us with a question stranger than the physics itself, one the equations cannot answer. If the longing for this kind of contact is so old, if human beings have always, in some quiet corner of themselves, felt the presence of the people they might have been, then why? Why have we always felt watched by versions of ourselves we cannot see, long before any physicist wrote down a wave function? Before we close the night by returning to the title head-on, we should spend a little time in the shadows, the real physics casts, the stories people tell when the longing for the other self gets dressed up as something it is not, is less than break time, equals 1s, is greater than number, part 11, the shadows, immortality, Deja vu, and false memories. The physics we have walked through tonight casts long shadows into culture, and I want to spend a little while in those shadows, gently, because they reveal something about why this question grips people the way it does. These are the stories the longing tells when it slips loose from the careful equations, the places where the wish for contact with another self shows up dressed as folklore. They are not evidence for anything, but they are worth understanding, both for what they get wrong and for the real human need underneath them. The first and most serious of these shadows is the idea sometimes called quantum immortality, and I want to handle it with real care, because it is the one that can genuinely unsettle people, and it deserves to be diffused rather than dramatized. The thought experiment goes like this. If every quantum outcome happens in some branch, then in any situation that might kill you, there is always at least one branch where, by sheer quantum luck, you survive. And since you can only ever experience the branches in which you are alive to experience anything, the argument claims you will always find yourself, from the inside, in a branch where you somehow made it. From your own point of view, the reasoning suggests you can never experience your own death. Now, I want to be very clear and very direct. This is a flawed, logical puzzle, not a claim about reality, and certainly not anything anyone should ever act on. It falls apart under inspection. It ignores the overwhelming majority of branches where you are not killed but badly injured, which are far more numerous than the lucky clean escapes. It treats survival as a simple yes or no when real bodies fail gradually, and it is unfalsifiable by its very construction, since it makes no prediction anyone could ever check from the outside. It is a curiosity about the logic of the interpretation, nothing more, and the responsible thing to say about it is that it tells you about the slipperiness of reasoning, not about your fate. The second shadow is the one called the Mandela effect, and it is far lighter, almost charming, in how it shows the longing at work. The name comes from the way large numbers of people share the same false memory, for instance, misremembering a famous event, a brand logo, a line from a film, all in the same wrong way. Somewhere along the line, the internet reframed this as leakage from a parallel branch, the idea that these shared false memories are traces bleeding through from another version of reality, where things really were different. It is a wonderful story. It is also not what is happening. The real explanation comes from the well-studied science of memory, which has shown for decades that human memory is not a recording, but a reconstruction, rebuilt slightly differently each time we recall it, and highly susceptible to the same systematic errors across many people who share the same cultural inputs. When millions of people are exposed to similar images and similar suggestions, they make similar mistakes. The branches are not bleeding through. Our memories are simply doing the ordinary, fallible thing memories do. The third shadow is déjà vu, that sudden, uncanny certainty that you have lived this exact moment before, that you have stood in this room and heard these words in some previous version of events. It is easy to see why someone would reach for the parallel self to explain it, why it feels like a memory belonging to another you. But here too, the real explanation, while less romantic, is well supported. Déjà vu appears to be a brief mistiming in the way the brain files an experience, a momentary hiccup in which a present moment gets tagged with the feeling of familiarity that normally accompanies a genuine memory. The sensation is real. The explanation is in the timing circuits of your own head, not in a neighboring branch of the wave function. I do not want to be unkind about any of these, because the impulse behind them is honest and worth respecting. People tell these stories because they answer a real longing, the sense that the lives we did not live are somehow still out there, that the selves we might have been are not simply gone. And the strange news of tonight is that the physics has made that longing slightly less ridiculous than it used to be. The branch copy may genuinely be real. The wall between you may be softer than the textbooks insisted. But, and this is the line I want to draw clearly, déjà vu is not the copy knocking. The Mandela effect is not a message from another world. The genuinely strange and genuinely defensible news is in the equations and the experiments, not in the glitches of memory. The longing is human and old. The evidence, such as it is, lives somewhere far more rigorous and far more interesting than folklore, which is exactly where we should return now, to the title itself and to an honest accounting of what we can and cannot say is less than break time, equals 1s, is greater than number part 12. If the copy knows about you, so let us return to the question we started with. Now that we have walked the whole house, room by room, and stand where we can finally see it clearly, what if a version of you from a parallel universe knows about you? We are in a position now to answer it not with a yes or a no, which would both be dishonest, but with something better, which is an accurate map of exactly where the question stands in 2026, after everything we have learned tonight. Let me give it to you in 3 clean beats, because the honest answer has 3 parts and each one matters. First, the existence of other versions of you is not a fringe idea. It is predicted independently by at least 2 completely separate areas of physics that never set out to give us company. Everett's reading of quantum mechanics, the most literal and least embellished interpretation of the most successful equation in science, fills reality with branch copies of you, diverging from you trillions of times a second in the atoms of your own body. And the cosmology of infinite space, resting only on the universe being endless and evenly filled, forces exact copies of you to exist across distances so large the units lose meaning. 2 roads, 2 kinds of you, arrived at separately. The copies are about as well motivated as any unobservable thing in science can be. Second, the wall that hides the branch copy from you is a process, not a law. This was the quiet revelation that ran through the whole night. Decoherence, the mechanism that walls the branches apart, is not a commandment written into the foundations of reality forbidding contact. It is a physical process, astonishingly fast and astonishingly effective, but a process of exactly the kind our crude machines already fight and slow down every time they run a quantum computation. The wall is real. The wall is, for all practical purposes, total, but it is made of circumstance, not of law. Third, and this is what changed in your lifetime, the certainty that the wall can never be crossed has been challenged on standard physics alone. The January 2026 argument, contested and unproven as it is, took the question of inter-branch communication out of the category of the impossible in principle and moved it into the category of the impossible in practice, which is a different and much more open place to be. It did this using only the equations we already trust, by combining the process of decoherence with the experimentally confirmed fact that different observers can hold different realities. The door it found is welded shut by the most extreme practical barrier in all of physics, and it may stay shut forever. But it is a door. I have to resist the temptation to overclaim, because that temptation is exactly what separates this channel from the ones that would tell you anything for a click. Nothing we have covered says that contact has happened. Nothing says it ever will. The communication argument may be wrong. The coherence it requires may be truly impossible, not just hard. The honest summary is narrow and strange, and worth saying plainly. Copies of you almost certainly exist, on more than one independent theory. The barrier between you and the nearest of them is a process rather than a prohibition. And the flat statement that you can never, even in principle, know about each other is no longer something physics will sign its name to. Let me sit for a moment with what it would actually mean if a branch version of you did know about you, because the title invites that, and you have earned the reflection. It would mean that somewhere, held in the same single wave function that holds you, there is a person who shares your every memory up to some fork a heartbeat ago, who made the choice you did not make, who took the turn you only thought about taking, and who is, across a wall thinner than any distance, aware that you are out there living the road they did not take, not a stranger, not an alien double. The closest possible other, separated from you by the least substantial barrier in all of nature, a barrier made only of the universe declining, so far, to let you interfere, and then turn the camera around, because this is the part the title does not say out loud, but always implies. By exactly the same logic, you are someone else's branch copy. To some version of you, a single quantum coin flip away, you are the road not taken. You are the other self they might, in some unreachable future, wonder about late at night. The relationship is perfectly symmetric. Whatever it would mean for them to know about you, it means equally for you to be the one they would know. You are not only the watcher in this story, you are also the watched. I think the reason this question stays with people, the reason it makes a good late-night thought rather than a passing curiosity, is that it quietly rearranges your sense of your own choices. We tend to feel that the roads we did not take simply evaporated, that the lives we did not live are nothing, mere might-have-beens with no substance to them. The physics we walk through tonight does not prove otherwise, but it loosens that certainty in an interesting way. It raises the serious possibility that the roads not taken are not nothing, that they are walked by someone who was you at the fork, somewhere in the same structure that holds you now. That does not have to be a sad thought, and I do not think it should be. There is a kind of generosity in a universe that lets every version of a life be lived, that does not waste a single possibility, that says of every choice, this one will happen here, and the others will happen too, elsewhere, fully, by someone who began exactly as you. It changes the texture of being one person, knowing that, even a little. Not in a way you could ever prove, and not in a way that should keep you up worrying, but in a quiet way, the way certain ideas sit in the back of the mind and gently recolor things. The next time you make some small decision and feel the faint pull of the alternative, the road you almost chose, you might remember that on our most literal reading of our best physics, the almost is not quite nothing, somewhere very close, separated from you by the thinnest barrier in all of nature, the almost is happening. I find, at the end of all this, that the feeling the title gives you is not something to be afraid of. The universe never promised to keep its versions of us apart forever. It only made the wall very, very good, good enough that for a century we mistook an extraordinary process for an absolute law. What the slow accumulation of physics has done, From Everett's refusal to the dust speck's decoherence to the 6 photons in a laboratory to a contested paper in the first month of 2026, is revealed that the separation we took for a law was always, underneath, just a circumstance. And circumstances, unlike laws, are the kind of thing the universe occasionally allows to change. So here is where I will leave you, in the quiet, with the lights low. Somewhere in the structure of the same equation that governs every atom in your body, that fired every neuron carrying the thought you are having right now, there may be a version of you, sitting in their own quiet, with their own lights low, asking the very same question about you. And for the first time in the long history of this idea, no one, not the textbooks, not the consensus, not the most careful physicist alive, can prove that the two of you will never, ever hear each other